Hello, this is a video tutorial for a one-sample hypothesis test where the standard deviation is known. It is based out of our book on the statistics section, chapter 9, page 429, problem 421, the Fowle marketing research problem. And let's start reading it together. Fowle Marketing Research Incorporated bases charges to a client on the assumption that telephone surveys can be completed in a mean time of 15 minutes or less. If a longer mean survey time is necessary, a premium rate is charged. A sample of 35 surveys provided the survey times shown in the data file named Fowle. Based upon past studies, the population standard deviation is assumed known with a sigma of 4 minutes. Is the premium rate justified? So we are going to first start looking at the information given to us. The mean time is 15 minutes or less. So it's going to be something to do with 15. If a longer than mean survey time is charged, a premium is necessary, a premium rate is charged. So what we're trying to prove in this is that the mean time is greater than the 15 minutes. So we're going to put that in the alternative hypothesis. What we're trying to prove is going to go in the hypothesis, the null hypothesis area. So greater than 15, which means the null needs to be less than or equal to 15. Now, we are wanting to actually write this out, not just leave it alone with this, because that doesn't explain really what you're seeing or what you're trying to show if anybody's just reading this. Your hypothesis, we're going to start with, again, the alternative hypothesis, and the average time it takes to complete a survey is significantly more than the industry average of 15 minutes. It's our research hypothesis. And in response, the null is going to be same verbiage. I can just paste it right there. The average time it takes to complete a survey is not significantly more than the industry average of 15 minutes. And we can get rid of this research hypothesis piece. So you're keeping the same verbiage in both hypotheses, and you're just saying it is not in one, not significantly more. Again, we're going to emphasize the fact that we are completing this hypothesis test with a level of significance. So we want to add that piece into it. So where mu is 15, which is the population mean, or you can also say it as the mean of all survey times, and where mu of naught is the standard, which is also called the test value or hypothesized value. We are still sticking with our level of significance of 0.05. And now we need to decide, are we using a lower one-tail, upper one-tail, or two-tail test? And we can see that by looking at our alternative hypothesis. What direction is the sign going in there? It's going greater than, so it's an upper. So upper one-tail test. Get rid of these other two. And again, let's reiterate, it's a management format. So each one, we want the first section to be the hypothesis test, second section, the p-value approach, the third, conclusion, and the fourth, the Excel results. Get in the habit of doing this format every time. Keeping it consistent helps the problem to progress properly. So we're going to look at the p-value approach. It also helps if you write this piece every single time. If p-value is less than or equal to alpha, reject H null. And really, you can just have that piece. You don't need the rest of this. This is just in here for a little bit more detail. When I say the rest of this, I mean the decision rule piece. If p-value is less than the level of significance, reject the null hypothesis. That does not need to be in here. It's just in my example, so you know what's going on. And this piece here If P is too low, HO must go, and get rid of that. So make sure you have this, because this little thing can cause a lot of pain. If you don't remember it consistently, if you're flipping the values back and forth, if alpha is listed first and p-value, it's just easiest to be consistent. Remember, p-value is less than or equal to alpha. You reject H null. So we are going to look at our data to find out. Look at this piece here. And again, it's the population, a standard deviation is known, which we put in there, 4, which was given to us in the original problem. And our hypothesized value is 15. So the rest of this is automatically calculated for you if you have everything plugged in correctly. I'm showing you the actual formulas here so that you can see where these numbers are coming from. So the only two values you are needing to input is this after you have all your data in this piece here. So your p-value, which if you recall is a one-tail upper. So one-tail upper is 0.0015. So let's move this over. If p-value is 0.0015 is less than or equal to alpha of 0.05, we reject or accept H null. So it is less than, p-value is less than our level of significance, so we need to reject H null. The p-value, where our t statistic, which again, looking at our data, our t statistic, in this case, a test statistic is z, which is 2.958. And this is the same direction sign as this one, less than or equal to. We're just putting it in another context. So where the test p-value is where the test statistic is less than or equal to 2.9580, our p-value is this same number right there. And really and truthfully, all I want to see here, this is nice to have if you want, but all I need is this, the decision rule, right there, and whether or not you accepted or rejected the H null. So in conclusion, this is just my format here, the data does or does not support the null hypothesis. We decided that it rejected it, so it does not support the null hypothesis. Instead, the data supports the research hypothesis, or the alternative hypothesis, that the population mean, this is from a different problem obviously, that the population mean of survey times is significantly more than 15% with an alpha risk of 5%. And we are getting this research hypothesis right up here. Is significantly more than 15. Put minutes. And we want to explain what that means. So in conclusions, chances are 19 out of 20, which is 95%. Again, we're getting this 95% because it is the inverse of the 5%. So 5% is the risk. We're 95% confident. Between the two of them, there's 100%. So 19 out of 20, and we write it in that way so that you're looking at 19 times out of 20. So 19, looking at 19 different examples of the survey time, 19 of those 20, 95% confident, is that a survey respondent will take more than 15 minutes to complete a survey. The managerial implication is that the premium rate should be charged. We're taking it a step just explaining what we found and how that influences, like what value does that give us. We are needing to charge premium rate because they are going longer than 15 minutes. So the Excel results, we are going back over to our Excel document, and you can just cut and paste this. Control C, cuts, and move that over. And you can either do a Control V, or if you do a right click, you can do paste as a picture. And again, you don't necessarily need to have these formulas being seen. I just want your data to pull right. It helps me if I can see this just for correcting purposes, but if you don't want that in there, that's absolutely fine. I'm just looking mainly for your values. And if you're struggling with having the values come out correctly, if you want to shoot me an email with an Excel document so that I can look at that and review it, I might be able to find out where you're entering some numbers wrong. So again, I'm going to scroll back up. Be consistent again with your management report format. First, hypothesis test, p-value approach, your conclusion, and your Excel results. We are going to keep with this standard throughout the class in our other other hypothesis testing. So you want to establish this correctly. You want to note that the importance of the hypothesis formation, because if you don't have this set up correctly, you're not going to pick which p-value, if it's an upper or lower tail, so which p-value to use. So that is going to change, completely can change your end results. So it all bases on formulating the hypotheses correctly. And this concludes this tutorial.